Welcome back. And if you have something that looks like this, you did it correctly. Congratulations. If you do not have something like this and you did it a different way, it's possible you still did it correctly. So for right now, you probably don't need to change anything just yet. But here's what we're looking at. I made separate lines for my debug.log where it says, Welcome to my guessing game. Pick any number. Don't tell me just yet. The highest number you can pick is 1,000. The lowest number you can pick is 1. And what that looks like in my console, to initialize the script, welcome to my guessing game. And each one shows on its own separate little line. Very nice. So now the question is, what if we want to be able to change those numbers and we don't want to have to go through and fiddle with all the different pieces of our code every time we change the numbers? That is when we start to use what we call variables. Again, if you refer back to your notes in the C# basics, there is a variables section. A variable is a particular type, has a name, and it contains data. For our purposes, we are going to be making an integer variable. So this variable is of type integer. We need to give it a name, and then we need to declare or set the value of the integer. So we have to try to be descriptive whenever we name our integers. So in our case, up here, above all this is where I generally speaking put all of my integers or variables, unless you need to isolate them, but we'll talk about it later. So we need to make an integer for our max value. So if it's int, it automatically recognizes it. See, popped up right there. And then space, because we know there's a space. That's turned blue, so we know it recognizes exactly what it is. We're going to call it max, okay? And then we need to set it equal to and a value. So let's say 1,000, okay? And then we also need one for our min. So int min equals 1 in our case. So now we have these integers. And were I to save this, this is great and all, but these aren't called anywhere in the code. They are set up, but they are not being used. So how we use them is pretty nifty. So I'm going to come down here, and actually I'm going to change my code a little bit because this looks a little crowded to me, and I don't like when my code is crowded. I like to move my curly brackets down a line. That way there's a little bit more separation between things. They're not all smooshed together. Okay, now I'm happy with that. So the highest number you can pick is in our string, but then I'm going to close the quotation marks and add plus max, which it knows whenever it pops up that it is an int and then it's in the game file and it is called max. So perfect, that's what we want. It recognizes it, it knows what it is. Again, I'm going to do this plus min. Recognizes it, knows what it is, perfect. And were I to hover over it, you can see that the highlight down here is also highlighted right here. Perfect. If I were to highlight this, this highlight would match this highlight. It shows you exactly where that integer is coming from. So I'm going to save this, and I'm going to come back to Unity. The script initializes, takes it a second. You see there is this this smoosh right here. That's because I didn't put a space at the end of my string text. It just put it immediately afterwards. So you note that it ignores these spaces because it's not part of the string. So I need a space here. Let's try that. See if that looks better. Much better. Okay, so is 100, and the lowest number you can pick is 1. Now, if I want to change those numbers, I can come back into my code and say I want to change it to your max you can pick is 999. Okay? Stop this. Run it again. Now this number has changed because the integer value changed and it picked it up from the code there. Now, say you want to change these integers on the fly. You don't want to have to go back and forth into your code and change hard-coded numbers all the time. And it is generally good practice not to do that. You want to make it so that if it's something that you think you're going to need adjusting, you need to not constantly be changing it inside the code because you could easily break things that way. So here's where we use a piece of code called serialize field. So you need a square bracket, serialize, spelled like that, field, I think. It's one word. Serialize field, like so. Nope, that's curly bracket. That won't work. You'll note that it's not giving me those handy dandy tooltips. That is because I was typing it right before these things and it was all smushed together, so it didn't know what was going on. If I were to type it right here, it automatically gives me my square bracket and it automatically pops up with serialize field. So that's just a handy dandy tip. So if I were to save this serialize field with my integers and come over here to my game, now I can click on my game object. Remember, this is where our script was attached, and I can set these numbers right here. So if I were to change this to 9, you can notice this turns into this. You can drag it around to change values. Sometimes that's useful, sometimes it's not. Those numbers will work for me for now. And then I hit play. Now these numbers match what I set right over here. And it obviously doesn't change while the game is running, but if I change this value over here while the game is running, you'll notice that it takes it back to what it was before it started running. So I changed it to 77. It snapped back to 9. So that's something important to note. If you change things while the game is running in this area in the inspector, it will not stick. It will not work. So I'm going to go back to my 1 and 1,000 because I'm not super good at math, and that really makes my life easier when numbers are very, very straightforward. So we now have integer min, integer max, and now we need to turn this into some kind of game, which means we need to give the person who is playing the game some instructions. So first, I'm going to copy debug.log because I don't need to type it out every single time. If you want to type it out every single time, sometimes that's faster, sometimes it's easier this way. It really depends on the person. But I'm going to change the string text inside of it. And I'm going to say, tell me if your number is higher or lower than 500, right there in the middle. Okay? And then the user needs to have some input instructions. So I need to tell them, type it out this time, see if we can compare the speeds here. So I want to tell them to push, let's say up if it's higher, push down if it's lower, and push enter if I got it right. And I need to finish my statement. Okay, so this is all well and dandy. I can write this in there. That's string text, so it's going to all pop up whenever I run the game. And it has instructions, but when I push up, nothing happens, right? Because I haven't told the code what to do with those buttons. So now I need to do some coding for button pushing. To find what you need for button pushes, I recommend you get comfortable with the Unity Scripting API. So if we go here and we look for input, obviously I have looked for this before, so I'm just going to put enter input. Let's see, input get button, input acceleration. There's lots of inputs. Any key down. So we're going to look for input get key down. So it returns true during the frame the user starts pressing down on the key identified by name, because we want to know when they press down on a button on their keyboard. So the Unity API has a description, tells you you need to call it from the update function. That's important. Function or method. Remember, those words are interchangeable. And once the state gets reset every frame, it will not return true until the user has released the key and pressed it again. That's important to know. It means that they could hold down the button and it's not going to keep guessing down, 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 down. It's only going to guess down again if they release the button and then they press it again. For the list of key identifiers, see the input manager. We'll deal with that in a second. And when dealing with input, it's recommended to use input get access and input get button instead, since it allows end users to configure the keys. We'll talk about that more later. Right now, we want them to use specific keys, keys that we have specifically told them exactly what ones they're going to use. So this one puts it in the void update. It says if, an if statement from your notes, input.getKeyDown, and then there's a string inside of that says space. The string is the name that we are looking for. Closing those. Curly brackets, if statements always include curly brackets. And then we need to tell it what to do when that happens. So we could also, instead of using that name, we can do key codes. I like key codes. They are more specific. They are less likely to be confused for the wrong thing. So we're going to be using key codes. So let's open this in a new tab. I'm pretty sure this is what we are looking for. Yes, it is. Okay. So key codes. Key codes are just the button that you're pushing. They are the way that Unity recognizes what has been pushed. So say I wanted players to press the 0 on the keypad. It's keypad 0, and it's the numeric keypad 0. They're pretty straightforward, not anything crazy. So right now, we know that we need to use the update, we need to use an if statement, and we need to know the key code of the things that we are using. And then debug.log can be put in there, or whatever else we want to put in there, we can do. So coming back to down here, let's see, we have our enter key, the return key and enter key. That's two names for the same button on a keyboard. Sometimes it says return, sometimes it says enter. Page up, page down. Let's see, up arrow. We need up arrow for whenever it goes higher, and down arrow whenever the number is lower, and we need enter for when it's correct. So, coming back over here, in the update, where I'm going to change the arrangement of things because I like my space right here. So, in update, we need to say if recognizes it. It's a code snippet for an if statement. And then parentheses, input dot get key down, right? Then parentheses, because we need to put our key code in there. See, it shows you right there on the tooltip. And if your tooltips aren't popping up, you need to just save everything, close out of Visual Studio, reload Visual Studio, and it will all pop right back up. Sometimes it gets finicky. So we need a key code dot up arrow. Okay, right? And then inside an if statement, we need curly brackets. So enter, curly bracket. I put enter again because I like to have my curly brackets on separate lines so it's nice and neat and easy to read. And I want the game to just tell me right now that I pushed the right button. So I'm just going to have it print to the console, debug.log. Nope, not lug. That's not the right word. Remember, typing and spelling, very important when it comes to Unity. So debug.log. And I wanted to say, you pushed up. Cool. Perfect. And now, if I were to save this, and I go back to my Unity, I let it reload its solutions, I run it, I'm going to push up. You pushed up. Now, if I hold it down, it only prints once, right? Because we used get key down, not get key pressed. So it prints each time I push up. Now, when I push down, or when I push enter, nothing happens, right? So here's your next challenge. I want you to pause this video and real quick, go through your code and make inputs for pushing the down arrow and an input for pushing enter. So go ahead and do that and pause the video and get that typed up, and then we will meet back in just a second. So if you did that, you should have something that looks like this. If key code up arrow is pressed, you pushed up. If key code down arrow is pressed, you push down. If key code return is, you pushed enter. Remember, return and enter, same key, just different names for the same key. So when you save this and you go to Unity and you hit play, you should be able to push up, and it pushed up. Down, you push down. Return, you push enter. Good job. Hooray. So you've got all that written out. Now, one thing you might consider is, what if your player is mashing buttons? So you could theoretically push multiple buttons at the same time. So I'm holding up right now and pressing down, and it's loading it every time. So if I push down, I can push up also. So we want to see if there's a way to make these statements mutually exclusive, meaning if you're pushing one button, you can't then push another button and have it work. So if we look at the website where we talk about if, else if, and else, remember this cute little flow chart that we got here. If you press 1, you go to the next room. So you may use if followed by else if to make sure that the player can't select both options simultaneously. So they can't do both things at the same time. So what we want to use is else if. We want to make it so that whenever we are pushing down, we can't also push up. That won't work. So we're going to go back over here, and we're just going to add, before each of our if statements, we're going to add else. Else if. And now, if we push down and then push up, it won't do both at the same time. So I'm pushing up, I'm holding up. Okay. So, got that all figured out. Everything should be good now. So, now we need to talk about a little bit more of making this a game. Right now, it just tells us, hey, you pushed a button, good job. It doesn't actually have any logic going on yet. So, what we need is, we need one more integer. We need to serialize it probably, just for the fact that we might want to use it later. And we're going to make it int. We're going to name it guess. Say we want to have our guess be changeable or called upon. So we're going to make a guess value, because if in a guessing game, your guess is going to continually change, correct? So if somebody says, no, it's not 500, you're not going to say, is it 500? Again and again and again. So you need a variable for that, because we need to be able to change it. Which also means we need to come down here, and where we put our string that asked if it was higher or lower than 500, we are going to remember to leave a space and then add plus. You don't have to have a space, I just like reading it that way. Guess, in which we know it's calling on that integer because it highlights both of them. And that's exactly what we want. So we've got that. Now we need to deal with this logic down here. So if a player pushes the up arrow, what do we want to happen? Well, we want to make our guess go higher, right? So we need to tell it to change our guess to a number that is higher than our initial guess. So let's say right now in here, we need to add some logic. So if you push up, then our next minimum should probably be, well, let's put it under debug.log. Okay, so our next number is going to be, our minimum has to equal the guess, right? Because now we know it is absolutely higher than 500. And so now our minimum equals the guess if they push the up arrow. And then we're going to call guess here. See what this looks like. So our new minimum is guess. We set this integer equal to this integer. And now we're going to print it in the console. So let's save it. If I push up, it now says you pushed up, and then it just says 500. That's not exactly what we wanted to do, but for right now, we just want to know that it is reading, it is changing the minimum to guess, and it is printing guess. So I'm going to do that real quick down here for down arrow. If you push down, then the max now has to be the higher number, right? Because we know the max now has to be lower than 500, which was our initial guess. And then we want to say guess, just to know it's in there. Okay, we've set that. If they hit enter, we know that 500 was the right answer. So maybe instead of saying you pushed enter, we say, I'm so smart, I got it right. Cool. That'll work for now. Now we have a guess variable. And we know that our guess variable is able to be changed. And we know that we can call on the guess variable and alter the guess variable based on what letter or what input is pushed. So instead of setting the variable like this, where it just directly changes it to min equals guess, and then debug.log just prints the guess, we actually need to give it some information here. So our minimum is now the guess that it previously was. It's going to read this code in order. So it set the minimum to the guess that we gave it, which was 500. Then we need to change what the guess is before it prints the next line. So we need to say some math here. And we're going to do this instead of randomly, we're going to do it very procedurally. So we're going to actually just take the numbers and add them together and then divide them by 2. So it's just going to have, like, take exactly the middle of both sets of numbers that we give it. So our new guess is going to equal the maximum, right? Because they pushed up, so we need to go between the maximum and the minimum, actually putting this in parentheses, maximum, and then we're going to add it to our new minimum, because remember now our minimum after it reads min equals guess is going to equal 500 at this point in time. And then we're going to divide it by 2. We're going to end the statement. So now, whenever we type this in, if I push up, instead of 500, it says 750, because 750 is halfway between 500 and 1,000. If I push up again, now it's 875. It's halfway between 750 and 1,000. It is going to change every single time I push the up button, because it is going to read that code each time in order, as if like brand new, because it's in the update function. So I want you to go ahead and pause the video for a second, come down here and do the same logic that you did right here and put it right here. But remember that you're going to have to change a couple of things around just to make it work right. Test it and come back and see how you did. So now you have min equals guess, guess equals max plus min divided by 2, debug.log equals guess, and you have that 2 times. You have it in if you push up, and you have it in if you push down. So now it just prints a number between your max and your min that you've set changing based on your guess, and it prints it to the console. You probably want to give your players a little bit more information than, and this is a number that now we're just throwing a number at you. So let's give it a little bit of a string. Let's change this to, let's see, is it higher or lower than space in the string and add plus guess. Looks very familiar, right? This is basically what's up here. But it gives them the instructions again, just in case they've forgotten what buttons they need to push or anything like that. It just reminds them, it's just good practice to keep your players' information on the table. So we have something interesting going on now. So we have 2 if statements that have some code inside of them that do exactly the same thing, right? They both say guess equals max plus min divided by 2, and then they print a new guess suggestion to the console. And that's great, but repeating things in your code unnecessarily is not something we want to do. So what we want to do instead is we want to create our own custom method. Now, you might be wondering how would we do this, and it's actually super duper easy. What we're going to do, we are going to select the thing that we know is going to be copied. We're going to right click, and there's a lot of stuff right here. So quick actions and refactorings. We want to refactor this as a new method right here, and it will automatically extract this method. It will put in new method. It will put in a new private void for us. And we can name it however we want to rename it. So let's call this next guess. And let's apply it. Now, you can see it already put it down there for us. We don't have to retype anything. We know everything should work perfectly. Whenever it reads this code, it is going to say you push up. It's going to set the minimum to the guess, and then it's going to run the method next guess. So right here, where it says all this information, we can erase this, and we can summon the method next guess, open parentheses, close parentheses, semicolon. So that will directly reference this right here. See, it pops up. Those are both highlighted. This is highlighted. It will do this that we have told it to do. So if I were to open Unity and run it, if I push up, it still works. If I push down, it still works. That is exactly what we want. So now that we have done that, we need to do a little bit more reorganization. So say we get the right answer and we want to restart the game. So let's change some things around here. So we have been actively changing these numbers as the game goes by, right? We have been manipulating them as the game runs. But if we restart the game, those numbers have already been altered. We want to make it so that those numbers reset at the beginning of the start of the game. So we want to make another new method, and we want it to encapsulate, we want these integers to be reset, and we want this information all in our new method. So first let's grab everything in here. right click, refactor it, and it will move it for us. And let's call it start game. Notice that whenever I first wrote start, it would not let me do that because we already have a void start and we don't want it to be void start. We want void start game. We are going to take these integers and we're just going to name them up there. We are not going to set them. We're just going to say these integers exist, okay? And at the start of the game, we're going to set them. So max equals 1,000. Min, oh, I see why I tried to put it in the wrong spot. I forgot to put my semicolon. Min equals 1. And guess equals 500. So you've got your start game in a private void, and you are finishing the game. You say, I'm so smart, I got it right. And how do you call your new start game to go back to the top? So let's tell the player that we're starting again. Let's play again. We need to include it in that string. So let's delete that there. There we go. Now it's not throwing up error message. And then we are just going to start the game again. Save it. If we come back over to Unity, it plays. It says push up if it's higher. I'm going to say it's higher. Let's say 750 is the right answer. I hit enter. The game starts again. All of our integers are back to what they should be. And we are all set. So congratulations, you've made your first game. It doesn't export or anything. It is just a game that you can only play inside of the console. But you have used code. You've learned a lot about how to place things, how to refactor things, and you are ready to move on to making this into something that can actually be interacted with. So that's what we're going to do next. We are going to take this code and we are going to turn it into something that has a user interface, has some buttons that are hooked up that the player can then play through several scenes, and we will feed information into those scenes. So we will see you then.